Hello everyone, welcome to my channel. In this video, we're going to solve this given exponential equation similar to one of those given at Math Olympiad competitions. And here we have m to the power of n minus n to the power of m equals 28. And so how do we solve this exponential equation? And so here, if you notice, we cannot use the laws of logarithm. But then we can use the laws of exponent, right? What do you think? The exponent is n, the exponent is m, and this is minus. If we can manipulate the exponents for both terms, then we can supply a formula to define these two terms, right? How do we do that? If we say put an exponent on both, like exponent 2 over here and exponent 2 on the other side, on both terms, then we can relate a formula similar to that kind of expression, similar to these two terms with exponent 2, right? Alright, so let's do that. So how do we do it? And so here, we have m to the power of n minus n to the power of m. And here, if you notice, this can have exponent of 1 on both terms, right? And what does it mean by that? Let's say 1 can be equal to 1 over 1, or can be equal to 2 over 2, or 3 over 3, right? The same, 3 over 3 is 1. These are all valued as 1. So, how do we manipulate the exponent then to make it with exponent 2 on both? So we can relate a formula related to these two terms with exponent 2. How do we do that? So let's change that exponent 1, 2, exponent 2 over 2, since 2 over 2 is equal to 1 anyway, right? So let's do that. So here we have m to the power of n raised to the power of 2 over 2. That's the same way equal to 1, right? So let's do that on the second term also. N to the power of m to the power of 2 over 2, and this is all equal to 28. And so now the exponent here is n, and outside the parentheses is 2 over 2. Likewise on the second term, 2 over 2. So from here, what are we going to do? So from the exponent formula, if we have like a to the power of m to the power of n, we can write this the same way as a to the power of n to the power of m. So we can manipulate this exponent. How do we manipulate it? In here, in our equation, we can manipulate that. We can do that. We can write the same way as m to the power of n, and we can put the denominator 2 underneath the n, right? And writing the numerator outside. That's the same way, right? Since we can multiply the exponent the same way, or we can alternate or switch their places, right? And so then the second term we do it the same way. So n to the power of m divided by 2 raised to the power of 2, and this is equal to 28. And so now what do we say? This is the whole thing considered as base and exponent 2. Likewise in the second term, this is the whole term. There's a whole expression as base and exponent 2. And so now, what are we going to do next? Well, since we don't know this, so these are all variables, m and n, so we can do substitution by designating the value of m to the power of n over 2, likewise on this n to the power of m over 2. So let a be equal to this value, m to the power of n over 2. Likewise, the second term, designate b as equal to this value, so n to the power of m over 2. So now we have a squared minus b squared equals 28. And so from here, if you notice, a squared minus b squared, can we recall a formula representing these two terms? We do have that formula, right? Difference of squares. So that is, if we have here a squared minus b squared, this is equal to a minus b times the quantity a plus b, right? So we can use this formula and supply it to the left-hand side of our equation. So we have now a minus b times the quantity a plus b equals 28. So now what did you notice? Left-hand side we call these two factors, right? And you can say that this is a smaller one. A minus b is less than a plus b, and our constant is 28. So we'll be looking for the factors of 28, right? So the factors of 28 are 28 and 1, or we say, since this is smaller, we just switch these numbers, right? So 1 and 28. So this is 1 times 28. That's equal to 28. And the other factor can be 2 and 14. And 4 and 7, right? 7 times 4, 28. 14 times 2 is 28. 28 times 1 is 28. So we have 1, 2, 3 cases. Case 1, case 2, and case 3. So we'll be supplying this value, factors of 28, to the left-hand side of our equation. So a minus b times the quantity a plus b equals 1 times 28. So this is our case 1. Okay, solving for a and b, we can say that a minus b is less than a plus b. Absolutely, right? So a minus b here corresponds to our factor 1, and a plus b corresponds to 28. So from here we add these two equations. Let's say this is equation 1 and this is equation 2. Equation 1 plus equation 2. So if we do it over here, we add a plus b equals 28. Add this together, we have this cancel, so 2a equals 29, and a is equal to 29 over 2, which is equal to 14.5. But since the value of a here is 14.5 and not a whole number, this has a fractional part. This is equivalent to 14 and 1/2. Well, the value of a requires a whole number, so this means that the factors of 28, 1, and 28 are not the right factors for the value of a and b. So now we're going to case number 2, where we have factors of 2 and 14. So we have a minus b times the quantity a plus b equals 2 times 14, factors of 28. So equating a minus b to 2 and a plus b to 14. So we have a minus b equals 2 and a plus b equals 14. Add these both. So we have a plus b equals 14. So we're adding both, canceling b. So we have 2a is equal to 16. So a here is 8. Right? So on here, substituting value of a as 8, so this is 8 plus b equals 14. B therefore is equals 14 minus 8. So b is equal to 6. So we have b is 6, a is 8. So the answers for a and b are whole numbers. Alright, so let's try putting this value in for a, for m raised to the power of n over 2, and b value of n to the power of m over 2 from earlier. So a is equal to m to the power of n over 2, and b is equal to n to the power of m over 2. So we have that value of a. 8 is equal to m to the power of n over 2, and b is 6 is equal to n to the power of m over 2. So from here, solving for m with respect to n, here write 8 as 2 cubed, right? And This is equal to m to the power of n over 2. Solving for m to the power of n over 2. Solving for the variables m and n. So we're raising the whole equation by 2. Right? So we ended up 2 to the power of 3 times 2, right? So 6 is equal to m to the power of n, right? And here, 6 is equal to n to the power of m divided by 2. If we're raising the whole equation to the power of 2, right? So we ended up with 6 squared is equal to n to the power of m, right? And so now, did you notice the base here is 2, exponent 6. On the other hand, here the base is 6 and the exponent is 2. But correspondingly, if you notice, 2 corresponds to m and 6 corresponds to n. And here on the right hand side is the same thing. 6 corresponds to n and 2 corresponds to m. So therefore, we can say that m is equal to 2 and n is equal to 6, right? And so, what about case 3, where the factors of 28 are 4 and 7? Let's try that. Case 3, okay? And so, we have here case 3, a minus b times the quantity a plus b equals 4 times 7. That's case 3 over here. Factors are 4 and 7 of 28, right? So, let's do this. So we have now a minus b equals 4 and a plus b equals 7. Add these two equations, so we have a plus b equals 7. So add this both, so we have this cancel. So we have 2a is equal to 11. A therefore is equal to 11 halves. So here once again we're having the value of a in fractional form. So this won't allow this answer for a, and of course therefore b will be the same thing if we substitute value of a over here as 11 halves. So it's 11 halves plus b equals 7. So b is equal to 7 minus 11 halves. So here the value of b is 14 minus 11 over 2. So the value of b is equal to 3 halves. This is in the form of a fraction also. And so now if you go back to case 2 where we found the value of m and n as 2 and 6 respectively on here. So now let's go and check our answer, the value of m and n, right? So let's check our answer. So we have our equation m to the power of n minus n to the power of m equals 28, and we have the value of m here as 2 and n is 6. Substitute that to our equation. So we have 2 to the power of 6 minus 6, that's n to the power of 2. Is this equal to 28? So here 2 to the power of 6 is 64 minus 6 squared is 36. 64 minus 36 is what? It's 28, right? So this is 28 is equal to 28. So this means that the value of a and b, or m and n, are correct. M is 2, n is 6. So this is now our final answer. And so that's all for now. Thanks for watching. And for those new to my channel, I would appreciate it if you can hit the like button and subscribe for more videos. I will see you in my next one. Have a great day everyone. Take care. Bye bye.